There is a plant growing in the ditch beside your road right now. Most people avoid it. Some spray it. Many rip it out without thinking twice. And yet, by dry weight, it contains up to 30% protein. Not incomplete protein, complete. Every essential amino acid your body cannot produce on its own. It carries dramatically more iron than spinach, more calcium than milk by comparable serving, more magnesium than many supplements sold in pharmacies. If you found that nutritional profile on a store shelf, it would be packaged, branded, and sold at a premium. Instead, it grows for free. No irrigation, no fertilizer, no supply chain. Its name is Urtica dioica. You know it as stinging nettle. And right now, somewhere within a few miles of where you are sitting, someone is spraying it with herbicide. If this plant is so nutritionally dense, why are we treating it like a weed? That tension between what it is and how we treat it is what this video is about. Before we go further, let's make this personal. Iron deficiency is not a distant country problem. It affects over a quarter of the global population. Most of those people are not starving. They are eating every day, just not foods that deliver what their bodies actually need. Low iron doesn't just mean a little tired. It means impaired oxygen transport, reduced muscle performance, chronic fatigue that slowly becomes normal. Now consider protein. Not just how much you eat, but how complete it is. A complete protein delivers all 9 essential amino acids your body cannot produce on its own. Beef has them, eggs have them, chicken has them. Most plant foods do not. That is why plant-forward diets are often told to carefully combine multiple foods to cover amino acid gaps. Stinging nettle doesn't require that. It provides a complete amino acid profile from a single plant source, and the iron numbers are not subtle. Dried nettle leaf contains roughly 41 milligrams of iron per 100 grams. Beef sits around 2.7 milligrams. Spinach, the vegetable most people associate with iron, is in that same range. That is not a marginal difference. That is a different category of nutritional density. This is not a supplement, not a wellness product with marketing behind it. It is a wild plant growing nearby, one most people have never seriously considered eating. That disconnect is what we need to understand. Let's look at what this actually means. Dried stinging nettle contains roughly 25 to 30% protein by weight. For comparison, beef jerky, one of the most protein-dense animal foods, sits around 33%. That puts a wild roadside plant in the same macronutrient category as processed meat, and protein is only part of the picture. Calcium levels in dried nettle reach roughly 481 milligrams per 100 grams, significantly higher than whole milk on a dry weight basis. Potassium can exceed 1,700 milligrams per 100 grams. A banana contains around 358 milligrams total. Magnesium is present in meaningful amounts, and magnesium is required for more than 300 biochemical reactions in the body. Most adults are chronically low. Vitamins A, C, and K are all present in substantial concentrations. This is not folklore. Peer-reviewed research documents nettle's nutritional density and its long history as a legitimate food source. And then there's the sting. The plant defends itself with microscopic silica needles that inject formic acid, histamine, and serotonin into the skin. That sharp burn most people remember from childhood. But here is the part almost no one is told. Heat destroys the sting completely. 60 seconds in boiling water neutralizes the compounds responsible for the reaction. After that, it is safe to handle, safe to eat, and its core minerals and protein remain largely intact. Cooking does not destroy its value, it unlocks it. We started with biology for a reason. History only matters once you understand what people were working with. Stinging nettle is not a modern rediscovery. It is one of the oldest cultivated fiber plants in recorded human history. Archaeological evidence traces its use back to the Bronze Age, woven into textiles, twisted into cordage, used in burial wrappings for the dead. That is not improvisation. Nettle fiber is fine, durable, structurally comparable to linen. People chose it deliberately, the way a modern engineer selects a specific alloy for a specific load. Then consider Ötzi, a man preserved in alpine ice for 5,300 years. Among his tools, nettle cord. A human surviving in one of the harshest environments on Earth selected this plant as reliable equipment. That fact alone speaks louder than any nutrition label. Move forward to 1916. Germany, cut off from global cotton supplies during the First World War, turned to stinging nettle as a strategic textile crop. Military uniforms, not experimental fabric, not peasant clothing, were produced with fiber content, up to 85% nettle. An industrialized nation, under wartime pressure, examined this roadside plant and concluded, this works, not as a last resort, as a functional material deployed at scale. For thousands of years, this plant fed people, clothed soldiers, secured tools, and wrapped the dead with dignity. And then, within a single century, we began spraying it with poison. This shift did not happen randomly. After World War II, the global textile industry reorganized itself around industrial cotton and synthetic fibers, nylon, polyester, materials that could be manufactured at scale, standardized, patented, and distributed through tightly controlled supply chains. That model created efficiency. It also created repeatable transactions. Every stage of production, from raw input to finished fabric, became part of a managed system. Stinging nettle does not fit easily into that structure. It grows without purchase orders, returns each spring without replanting, spreads without contracts, licensing, or proprietary seed agreements. No company owns it. No patent restricts it. It exists outside centralized production models. In a system optimized for scale and predictability, plants that operate independently tend to be sidelined. Post-war agricultural policy across much of the Western world increasingly favored monoculture. Single crop systems optimize for uniform yield and mechanization. Fertilizers, pesticides, annual seed purchases, anything growing outside that framework was categorized as interference. The word used was weed. Broadleaf herbicides were developed to remove non-target plants from crop fields. Stinging nettle is a broadleaf. Over time, the infrastructure dedicated to eliminating it became far more developed than any infrastructure built to cultivate it. And from a market perspective, cultivation offered little incentive. Nettle cannot be patented. It does not require annual repurchase. It produces food and fiber without recurring industrial inputs. That does not make it dangerous. It makes it economically inconvenient. The 20th century favored crops that integrated cleanly into large-scale, input-driven systems. Stinging nettle did not, so it was gradually treated not as a resource, but as something to remove, not by secret decree, but by the quiet logic of markets prioritizing what can be standardized, scaled, and sold. So what can you actually do with this? Stinging nettle is not exotic. It is not rare. It grows across North America, Europe, Asia, and parts of Africa, along roadsides, riverbanks, forest, and the disturbed soil around farms and empty lots. It does not hide. It grows where people live. You can recognize it by its heart-shaped, sharply serrated leaves, a square stem, leaf pairs growing opposite each other, fine hair-like needles covering the surface. The source of the sting. It usually stands between 1 and 4 feet tall, and if you've ever brushed against it and felt that sharp burn, you've already met it. Harvesting is simple. Wear gloves. Take the young growth, the top 4 to 6 leaves. Harvest before flowering for best quality. Then comes the part most people never learn. 60 seconds in boiling water removes the sting completely. After that, it behaves like cooked spinach. It can go into soups, sautéed with garlic and oil, blended into sauces, folded into pasta. The leaves can also be dried and steeped as tea, a mineral-dense infusion used across cultures for generations, or dried and powdered, added quietly to meals as a concentrated source of nutrients. No store required, no subscription, no proprietary input, just recognition, the ability to look at something that has always been there and understand what it is. There are 2 kinds of people who walk past a patch of stinging nettle: those who see a nuisance to avoid, and those who see food, fiber, a 5,000-year human relationship with a plant their ancestors understood well. The plant has not changed. What changed is how we look at it. You now know what it contains. You know how to recognize it. You know how to make it edible in 60 seconds. That knowledge knowledge is simple. What you choose to do with it is up to you. If this video gave you something worth keeping, subscribe and share it with someone who still thinks this is just a weed, because the difference between a weed and a resource has never been the plant. It has always been understanding.